Hi, thank you for having me. Awesome to be here. Thank you all for those who are joining us. A quick introduction about myself, and then a bit about what we're going to talk today. So I myself started engineering school, and then went to Intel. Spent quite some time there, starting with heavy operating system kernels, and the deep components of what's going on inside a PC on your laptop. And around 2009, out of necessity, had a chance to go into data, machine learning, and automation. Saved quite a lot some money in that, and decided that it's going to be my career path: data automation or knowledge automation. And around 2016, after several ventures, and both inside Intel and outside of Intel, started Dataloop. And we'll see what we'll discuss what Dataloop is about as we go along. So when we started in 2016, you could get to see the left was kind of analysis done around 2016 that we did before we launched Dataloop. And on the right, you could actually see the full, today we call it MLOps platform, and what we had in mind. Now, pretty soon, we understood that this is very big, and pretty soon we also scrapped the whole plan and started on focusing on labeling for 4 years. So to be honest, we thought it would be much more shorter than 4 years, but that was kind of the focus point that we choose, even though we had a full data pipeline framework running, even with customers. We scraped the whole thing, and we understood that if we focus on, like, if you take a look and focus on the machine teaching, and that's something I remember closely when working on these projects at Intel. The right expert with the right data is much more valuable than a lot of data, just a lot of data, or a lot of data without the expert. And labeling, kind of this simple action that everybody tend to kind of discount, is actually, this is the teaching action. This is, if we want to talk more in a more technical manner, this is where we point the signal out of the noise. And this is where we started. Notice this image, by the way. It's very, people are still asking me today, right? With DALL-E and GPT-3. Notice how this image was generated by Stable Diffusion. Notice how it's, on one hand, it's kind of matches the description, but on the other hand, you would find that it doesn't really make sense. There are deformations, and some things don't make sense. And people are talking that generative models do not require labels. I would say that they're requiring labels on the output rather than the input. And you could expect the prompt engineering to become, prompt engineering is the labeling of generative models. And then we started kind of asking the most basic questions. And this, whatever I'm talking about now, is kind of a part of a full book I've written, 9 chapters already online that you could get an access to. And all in all, it's expected to be around 14 chapters. But I found myself trying to kind of narrow down and make things much more simple and much more crisp, and I started asking simple questions, and that led to a lecture I gave to some Google executive folks around two years back, trying to, they were not coming from the field of deep learning or AI, but they were kind of technological folks. And I found myself kind of narrowing the same motive and the same principles until I've started writing that book. And you don't need more than cats. That's what I like to say. So we'll see a lot of cats, and whatever we see here on cats, you'll find that it's much more broader than just cats. It's goes to every piece of data and every domain that you'd like. So I started with asking what is intelligence. I couldn't find like a good answer, and it took some time to narrow it to good answer. And the definition I ended up with is the ability to achieve a goal in changing environment, right? Without somebody to guide us. And that's very important because it means something, we have a goal. The environment is always changing. In some cases, like self-driving cars or autonomous frictionless shopping, the environment must be even adversary, right? People want to, they have motivation to have the system miss them picking up a product from the shelf. And naturally, we wanted to learn, right? Without external guidance. And this is intelligence. And we then came up with those three pillars that we found a Dataloop on. And we found those straight up. And those three pillars were quite, today they might sound trivial, but I was kicked out of many rooms by saying that. It starts with the fact that we don't care about modeling in AI, in Dataloop when it comes to AI. Modeling will be automated, and we care about data development. Essentially, I like to say that how did we end up building a data-centric platform? We just built a machine learning platform, but we were not allowed to deal with the models for 5 years. And we only dealt with the data. So AI is about data development, not about data modeling. The second pillar was that humans are the only source of knowledge. You don't have knowledge that doesn't come from humans. And you have like the knowledge can flow from humans to the models in many ways. In synthetic data, it might be folks who are making 3D models and by making those 3D models, they're actually putting the rules of how objects and formations looks like. It might be folks who are using generative models, but then screening the results to make sure that they're right. And it might be simple coding of rules, right? Still, the coder of the rules actually uses their knowledge in order to teach the machine. But at the end of the day, machines cannot learn by themselves. And human processing is a core. The last part, which was so significant that we actually named the company after that, is that learning systems will always have data feedback loops, right? Kind of distilling the information. We'll talk about what information is in production. And that was, I would say, I think this was the most criticized thing that I got along the way, right? Claiming that labeling will be in production, not just only post-launch, not only in the initial phases of R&D. I would say that today, as we see it on our customers, many of the models behave that way. And these are our pillars. And the first question that I'd like to ask, and feel free to answer yourself, like, what is data? If you have to use one word, you cannot use 2 words or 3 words. You could use one word to replace the word data with. What would you use? Right? Take a moment to think about it. You have to use a single word. So the word will be probably a fact, right? Or anything around that. Objective fact. You cannot argue with data. Data is a fact. Here we can see 2 pieces of data, right? Both of them containing some amount of pixels, and those pixels have values, and we cannot argue with those values, right? The fact that one has some details in it and the other one doesn't, that's irrelevant, right? It's our interpretation. So data is a fact. Now, if I'll ask you to do the same exercise, this time with what is information, right? Again, a single word. Information will be an opinion, right? You might look at it as a question and an answer, right? Here you can see the same 3 facts, the same pieces of the 3 pieces of data. But different question is being asked on each time, right? And different information, therefore, will be represented by this data and the answer, right? Notice that the answer is the label. So information is an opinion, a question and an answer, and naturally it's opinion of those who are selecting what to ask and what to answer. And since we are the only source of information, we define both the question and the answer over the data. And that's really important. I'm calling it the primary bias. We tend to think about bias, and we'll talk a bit about bias later on. We tend to think about bias as something that is, we have a problem with the data. The bias starts way, way, way earlier. The bias starts with the data we choose to collect. The bias starts with the questions we choose regarding those data, right? And very common today talk about biasing and whether it's gender or ethnicity inside data. The developers just ignore the question of those terms inside the data they've collected and inside the models that they've trained. And then if I ask you to replace the word knowledge with one word, what would that be? You can replace the word knowledge with one word. A good word will be a skill, right? Once you have a knowledge about some area, you have a skill. And if I'm telling you now to participate in this exercise, you have here two photos of cats, right? If you have to guess what type of cat it is, right? Not everybody have the skills to do that. You have to understand the details. And now we'll even add another detail, is that these are two different type of cats. They're not the same. And only an expert will actually be able to tell that. And that's knowledge, that's skill. And by the way, I'm not a cat. I don't have cats, and I'm not a cat expert, but once going into those details and choosing cats as my subject, I became kind of a cat expert. Once you go to the skill, and every time we work with a customer in Dataloop, we are amazed with the amount of details they go into the data, right? And here you could see those two nice cats. Actually, one is British Longhair, and there are actually two types of Persian cats. One was not before. And if you'll go to an expert, they'll explain you the differences, right? They'll explain you why the left is the left and the right is the right, and the different types. And there are actually a numerous amount of forums that discusses those differences. What are they meaning? What are their breeding? Like cat breeders are very, very enthusiastic about cats, right? But for an outsider like me, and maybe most of you out there, these are just cat. I would say Persian, Angora on a lucky day. So knowledge is skill, and skill will always mean details, and that's very important because this is the real paradigm change, right? We're not programming machines by code. We're programming machines by example. We have some domain expertise, in this case, a cat. And the cat has a lot of parts and details in it. But once, if you would like, in the 90s or the early 2000s, you would ask an expert, an algorithm expert, to build a cat detection. They will immediately try to transform all these rules through code, right? They will do some kind of analysis and feature extractions, and then they're likely to go working on MATLAB and then implement that on C++ or something. But when it comes to the true revolution of what's happening and what we tend to call today AI, this true revolution is not about intelligence, right? It's about the ability to take those simple details of knowledge, right? Not only identifying a cat, but identifying what type of cat it is, and just throw it into the machine with the right labels, and the machine will figure out the rule by itself. This is quite remarkable. And if we think about what it means that 60 years, only programmers or software developers or software companies had the ability to automate knowledge. You might call it automate business rules, right? Because usually it's driven by business. But what happened now with the age of AI is that if you have access to data and you have access to knowledge, you will be able to generate an application or some kind of an automation. You might call it even an IP without code, right? Just using. You could already see, by the way, GPT-3 writing applications by itself. So if you have an access to knowledge and data, you could now create something. And we could all see how the Stable Diffusion and DALL-E and the rest of them are now allowing everybody to be kind of an artist, right? It's your ideas that are now limiting you rather than your painting skills or how you work well with a brush, or Photoshop. And this is a much bigger revolution than that. If you have ideas, if you have creativity, if you have access to data, and if you have access to knowledge, you will be able to generate meaningful products. And so what was reserved to half of the population, 0.5% of the population, there are probably 0.5 developers in the world, is now gradually being open to the rest. So what happens when the other 99% of the population is no longer blocked? Probably this is nothing but remarkable. So even though it's not a promise of intelligence, and those of you want, we can spend an hour or two, I would argue that there is no artificial general intelligence, and nothing like that is even coming soon. And by the way, that's a good thing, because if an AGI exists, the first thing it should do is acknowledge its threat, and we're its #1 threat. So maybe not having an artificial general intelligence is a good thing. But at the age of no-code programming, the ability to build a very powerful very accurate cat detector, even with a lot of cat types, is the age of, this is the big promise. It's the age of no-code programming. And coding by examples rather than coding by programming language is the true revolution here. And that's naturally sparked a wave of knowledge automation opportunities, right? You could see the different opportunities here, right? When it comes to retail and medical and naturally autonomous cars, everybody are familiar with, and smart agriculture and surveillance and you name it, right? And if you think about it, there are for every action we do, there are two parts, right? If you want to automate labor, right? Want to automate people, and that's everybody doing with AI, that's essentially, we're part of that. We can automate the physical part and we can automate the cognitive part. But if you take a look on what's self-driving car, the robotics needed for self-driving car is there for decades. The real breakthrough is the ability to automate the knowledge of driving, the perception of driving, like the perception, the planning, Ego Road, and those who are in this field probably are familiar with that. And you could take a look at that, and that's kind of remarkable opportunity, but then you kind of get confused, because I drove to my house today. When I went to shopping, I talked with the cashier. Maybe I have a self-checkout with a barcode, right? And when I go to the doctor, they still look at the documents, right? So the AI adoption market is very, very slow. And the question is why? Why the adoption is so slow? By the way, you could see amazing demos always. Lab results are always great. But once you start going into production, you would see that everything, it's, I think we started, if we take AlexNet as the breakthrough moment, right? Almost a decade into AI, and we're still not using it on our daily lives. And think about what smartphones or the internet has done in the equivalent period. So it's much slower. And it will take probably 3 to 5 years to bring, we can argue whether it's how simple it is, but the simple AI to production. It will take 3 to 5 years. And this time, naturally, it accelerates, and it's much slower today, right? And that's what we're working with our customer on shortening those cycles. But let's take a real example, right? And it will kind of show the lagness or where the pain points are. So around 2016, Google Labs has shown a human expert level, right, with retinopathy. It's the ability to identify diabetes on an eye scan, all right, on the retina scan. You could see how such a scan looks like. Anybody who works with data would probably acknowledge that these scans are pretty stable, right? It's not like self-driving car where an elephant might jump into the road and you didn't have elephant in your training set. It's a lot of images of those retina scans with different type of dots and naturally blood vessels, but that's kind of the domain. And the promise, the business promise, or the value promise was like amazing, right? From 10 weeks of cycle, you could be screened for diabetes within 10 minutes. And the Thailand government went to a pilot because they want to screen the entire country. They have only 200 specialists in the war in Thailand, and that was an amazing opportunity. And so they prepared a pilot, and after 2 years they deployed, and they deployed it to the system, edge to cloud, and they train the nurses how to use the system. Right, the nurses of that system were trained of how to take the sample, and they used about 11 clinics over 8 months. And then came the notice, we're already to 2020, right? 4 years later comes the results. To put it in a simple manner, more work is needed, right? You could see that the MIT tech review, Google Medical was super accurate in lab, real life was different. But what were the I would say the main conclusions? First, the poor lighting conditions, right? This is another way of saying no, real world data is very different from what we've seen in the lab. Quality of the image, different, a high degree of variance because of different machines, connectivity of the data, and high rejections of the images. In other words, they reached the conclusion that that they have to connect into the kind of create a learning loop. I would, if you don't mind, I will call it data loop, in order to create a continuous learning system and gradually generalize the model for the different scanners, the different condition, the different lighting, the different patients, et cetera, et cetera, et cetera. And that took 4 years, right? From an amazing lab results that shows we're beating the human expert, or at least on par with the human experts, to actually acknowledge a failure. And now I trust Google to bring that into production. I know they're working on that, but this is kind of to emphasize that taking models to production is not that easy. It's not just like it's software. And around 2021, when we talked about that data loop, we were no longer, I would say there are folks that said that before, but we started hearing those principles of creating those data loop in order to kind of distill the information and generalize the models all around us, with AngularNG kind of shooting out for a data-centric movement. And the principle with those, everybody's solution, right? Everybody that's building a learning system, there is a very simple principle. You want to build a data flywheel effect, and that data flywheel will obey to 2 rules. The faster you spin it, the faster you learn. The more data you put in, the more accurate your model will be. And it's all a game about how fast you spin it and how much data you are able to feed in while you're spinning it. And in Dataloop, one of our customers using only one data scientist and a developer has actually beat in time to market a corporate that has a team of 40 data scientists and developers facing them. By the way, the company was acquired by this corporate. So how come a team of 2 defeats a team of 40 with way much resources? So it's very, very simple. They spin that data loop very fast and automated the entire labeling pipelines, all the way that the customers are labeling in production. They harvest the labels from the customers, and that goes back into the model. Created like a learning speed that is unimaginable, able to consume massive amount of data. And when their competition, which was like a big corporate with like 20x the resources, benchmarked their solution against their own, they were like overwhelmed. How could that, such a small team could achieve those results? So what blocks that wheel? It's very simple. If you want to scale 10 servers to 1,000, it will take you probably a few minutes on Amazon, right? It will cost you a lot of money, but it will take you a few minutes. But if you want to scale 10 labelers to 1,000, it will take you years. Now, naturally, folks doing AI on production not always have to go to the thousands of people. Sometimes dozens or hundreds are enough, but you get the point. Scaling labelers is just like scaling software developers in some kind, or scaling your R&D in some kind, which actually it's not that simple, and it always have the issues with it. And the questions are, what is so hard with scaling those labelers, right? Right? Why can't I just, take my recipe, we call it in Dataloop recipe, take my recipe, bring a few, even a few dozens or hundreds, and then go to thousands and generate more data. So why is it that so hard? So if we go to kind of try to understand, explain why it's so hard, we'll use this cat analytics, or we'll use cats just to taste a bit of what's going on along the way. And imagine that we want to develop a cat analytics solution. So if we talk about those machine teachers, and I think we mentioned that the knowledge flow, if you remember, comes all the way from the literature, right? I've shown you some images of cats, and I could explain you why the Persian cat is not the British Longhair. But at the end of the day, you would see that the last part of the knowledge flow is from the local experts, or to the model is by the human labeler. So assuming that we did all the trivial things, right? Which collecting cats, we did some modeling, but then once we will deploy it, we'll start see edge cases. And this is probably the most, everybody will talk about edge cases. And even when it comes to simple cats, you will see a lot of edge cases. So in order to deal with those edge cases, you will have to actually train a lot of models, see where the misses are, and use, again, human in the loop. There are anomaly detections and a lot of algorithms that can help you do that. But at the end of the day, it's about collecting a lot of data, because it's all about probability when you will see that edge case. Then you will have noise, right? In many cases, the signal to noise ratio will show you that, it's a cat, and you're in a very, I would say, tough position, because if you see a cat in that garbage, every model that sees cat in that garbage pile will actually be very, very variant, will actually be very, very highly overfitted. But humans can actually detect and screen the noise, doing adaptive signal to noise ratios, what models can't. Then you have ambiguities, right? And you could see here two cats, but one of them could be nice to pet, and the other one you don't want to see in the around you. So, and you always have ambiguities, right? And then comes the question of boundaries. What is a cat, right? You could argue that all of these are cats, but if you remember the primary bias, what do you need your cat detection for? If you need your cat detection for product recommendation, maybe the left one here is right. But if you need it for analyzing cats on the streets, then all of them are wrong. So it's very, very dependent. Remember, information is subjective. We choose what to ask. We choose the right answer. Add the lighting condition or different environments, and you'll always have different environments. And you will find that that this adds another layer of complexities, right? And then you're starting to have bugs, right? I will not cover the variance and bias. I would assume that all the folks here knows what variance and bias are, but they are in the data all the time. Could you identify the bias here in these images, right? Take a look for a moment. You would see that all the cats have the same position, but more important, all of them are the sofa. These type of images will actually pick up sofa properties as cat properties because of that bias. And it's not that simple to identify that once you have like millions of them. You could see here the variance, right? Where the cat here, not that trivial. The same, any model that will identify a cat here will be highly overfitted by design. How to overcome that, that's a different question, right? But the real problem is that bias is part of intelligence, right? If I ask you what animal behind the black box, likely you will say cat, even though there is a single indication that there is a cat behind that black box. And the cool part is that you'll be right. There is a cat behind that box. You'll be answering that. This is your biased answer. And you'll be correct, because bias is part of intelligence. The problem is not having bias. The problem is having static bias. Dynamic bias is what intelligence is built from, and static bias is what our models have. At this point, I will summarize, right, without going too much into the into the details, but I will summarize in that as you go down to the rabbit hole with cats, right, you'll identify that there are many types of cats. They have a very detailed ontology, right? Talk to any cat expert, they will explain to you, and you will find that the data becomes very, very expensive and I would say detailed, right? Even if you go ask how many cat types there are in the world, you'll find that there are 3 cat associations. They do not even agree how many cat types are in the world, right? These are 3 very, very respected institutions dealing all today with cats, just deciding how many cat types are there. Not that simple. So as you go down the rabbit hole with every domain expertise, you'll find the data becomes more complex. You'll find the domain knowledge become more complex. You will find data become more expensive, and naturally the labeling of that data becomes much more detailed and expensive. Let's stop for questions. How does your company manage to collect data and naturally not overfit the results? So it's not about not overfitting. You will always overfit. The question is that you need to overfit. Think about it, that you need to generalize as you deploy more and more and more. Well, you cannot avoid overfitting. So the key here is that as you collect more cases in more locations, to kind of reconverge or retrain your models to deal with that. That's the whole point here. You cannot avoid overfitting. I hope that was clear enough. By design, because you cannot know what you don't know, right? You cannot train a model on California roads and expect it to work in India. Any tips to avoid object class overlapping in the training? Oh, that's an interesting one. So there are many things you should be doing probably, right? Both with negative and positive example. When you're talking about overlapping, I would assume. Okay, but I would assume that you're talking about there are two scenarios, right? You have 2 categories, right? That are very similar, like I've shown before. In these cases, you will have to go deep down into the details of what makes them different. If you're talking about the same category, like 2 cats, right? And you want to avoid the overlapping, you actually have 2 options. The first one, if you want to count, I guess that you want the overlapping, right? If I have 2 cats, I do want them to be overlapped. The way to always deal with these type of things is actually to create more categories. That might help. In other words, you could create like a cat or multiple cats, right? And you will actually identify that there are multiple cats in that scene or in that box. But essentially, at the end of the day, it's very dependent on what you want to reach. So I hope that made sense, right? Okay. Yes, so you're saying, but if you want to count the cats, yeah. So again, it depends on the questions you ask, right? If you want to count the cats, then you have to allow overlapping. Then the question happens, because you allow overlapping, what happens if you have overfitting and you have like 3 boxes, like cat A, cat B, and like big box containing cats? In this case, you'll have to separate it with a different category. Costs you more money, but it's a general thing. Always assume that more detailed question will cost you in more labeling and more training or more precision. But that would kind of answer that. If you really want to do it the best way, you probably should actually separate models, right? You should cut. If that's really important for you to understand how many cats are there, you will actually cut every cat, and then you will put it through a classifier or something that will tell you, do you see a single cat here, right? And then you'll be able to do a very precise counting. So it's very dependent again. And at the end of the day, if you really want to avoid the overlaps, don't use bounding boxes. Use instance segmentations, right? That's take it to the next level with cost and everything. Any other questions? Okay. Awesome. So thanks and appreciate the time, and welcome you to kind of read the books read my book in our website, and you'll see you got the feeling of what am I doing there, right? So, but it's in much more details. So thanks for the time.